Skill Practice B1, Essential Pre-Algebra Skills. Here we go. All right, so we're comparing two numbers. The one on the left is written in scientific notation, and the one on the right is a fraction. Hopefully you know that 2.43 times 10 to the negative 1, that means just slide the decimal to the left one place. And 2/7 is going to be 0.285714285714, going on and on forever. Well, when you look at this one, they're tied in the whole numbers. They're tied in the tenths place. The hundredths place is what gives you your answer. So 24 hundredths is less than 28 hundredths. There you go. All right, moving on. We have any number that is rational. So looking at all these numbers, which numbers are rational? Rational means any number that can be written as a fraction, or any decimal that terminates or goes on forever with a pattern. So if it's a decimal that stops or has a pattern like a bar over it, then it's okay. Or anything that can be written as a fraction. Hey, a ratio, fraction, ratio. Rational numbers are any numbers that can be written as a fraction. So of these numbers, square root of 49, hey, that's already a fraction. This works out to 7. This is a fraction, therefore it's rational. This has a repeating pattern. This works out to a non-terminating decimal, but it goes on without a pattern, so it's irrational. So those are irrational numbers. Moving on. Square root of 60 is between what pairs of consecutive integers? Okay, square root of 60, let's see, something times something is 60. There's not anything exact. It's going to be between two integers. So 7 times 7 is 49, 8 times 8 is 64. So it's going to be between those two. Now you need to remember that negative 7 times negative 7 and negative 8 times negative 8 would also be between those two. We're going to move on. Negative square root of 196. Hopefully you know that square root of 196 is 14. Because 14 times 14 gives you that. And then since there's a negative in front of the radical sign, your answer is going to be negative. And that's all you need to know for this. This is also something you could use with your Desmos calculator. Ideally, this is something you'd know off the top of your head, though. Just don't forget that negative. All right, what is the percent increase if 15 changes to 21? Now I've got a video that goes into more detail with this. Basically, if you can remember difference over original and then make it into a percentage, that's basically it. So here's the gist. There's two ways you could do this. So let's say something cost $15 and now it's costing $21. That's going to be a percent increase. You just do difference between the two numbers over the original times 100. I'm going to show you one way to do it and then another way to do it. You do your difference, 21 minus 15 over the original. It said 15 changed to 21, so its original value was 15. So then you get 6 over 15, and you can work it out like that. Or you could use a proportion. You can do difference over original equals something over 100, and you get the 6 out of 15 equals something out of 100. So you get the same, and I'm showing the cross product trick here, but you could also do that ricochet proportion trick that we've talked about in class. Either way, you get a 40% increase. Moving on. So we've got a principal amount of $200,000 and a loan interest rate of 5.3%. What is the total amount of money owed if you pay off the loan in 15 years? And we should say this is an annual interest rate. All right. So first we're going to do I equals PRT. We're going to do the setup. 200,000, 5.3%, 15. Work that out. Now, in the last round of problems, we were done. That was the interest. But now they're saying what's the total amount of money owed if you have to pay this off in 15 years. So you just principal plus your interest. So your principal amount was 200, and you're adding the interest. So you really have to pay $359,000. If you're going to borrow $200,000, you have to pay back $359,000. It's a lot of money we're talking. All right, angle relationships. When you have one intersection. So in this picture, they want you to find all of the missing angle measures. All right, so they gave us 30 and 90. And what you can do is use the information they give you here to figure out the rest of the angle measurements. If you look carefully, you see that these two angles are vertical. So two angles that are directly across from each other are going to be the same. So vertical angles have the same measurement. And then you can look here, this 90-degree angle and this other angle are 90 because they are vertical. Now we have this missing angle here. If this angle here is 90, that means these two will add up to 90 because they're complementary. So 30 plus something is 90, it's going to be 60. And then if these two angles are vertical, same. We're going to move on. Okay, volume surface area for cones and pyramids. What is the volume of this figure? Okay, this is a pyramid. We've got some information, 8, 7, 6 in this pyramid. So they're asking for volume. So volume is 1/3 big BH. Big B, you need to realize, stands for the area of the base face. The area of the base face. And the base face is this rectangle that's on the bottom. So you're going to figure out the area of that rectangle by going 7 times 8. And then when you set up your formula, you're going to go 1/3 times the area of the base times the height. 1/3 times the area of the base, I'm getting that 7 times 8 and putting it here. And then times the height. You end up getting 112 inches cubed. That means there are 112 little cubic inches that would fit inside of this pyramid. It holds 112 cubic inches. We're going to move on. All right, so we have changing attributes. We have our original figure, and then we're going to see what happens to the figure when its height is multiplied by 3. So our original figure's dimensions are 2 by 1 by 1, 2 length, depth or width of 1, and height of 1. Currently the volume is made of 2 blocks. The surface area, 1, 2, 3, 4, 5 squares that we see covering it, but then there's also 5 that we don't see, so it's a total of 10 squares covering these. All right, so then we have our height times 3. Well, let's see what happens when we have our height times 3. We're going to triple the height. So now we have a 2 by 1 by 3. So the total amount of blocks, if we multiply our height by 3, we just take our blocks and multiply it by 3. 2, 4, 6. Now the surface area is going to increase, but it's not going to become 30. It's going to increase though. The front side will triple, the side will triple, but that top side did not triple. So we're just going to say a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then double that. So 22 squares is the surface area. We're going to move on. The transformation that took place from A to A prime, or the image of A. So A was at 3, -2, now it's at -2, -2. Okay, so it looks as if the only real thing it can do is move left, which is a negative horizontal direction. And it's going to be horizontal translation of -5. there's no reflecting going on. If I was reflecting over the y-axis, it would have the same distance just on the other side. That's the absolute value. They'd have the same absolute value. Or if I was reflecting over x, it would be somewhere up here. So it just slid left 5, which is horizontal translation of -5. Okay, another Pythagorean theorem problem. In the last round of problems, I wasn't giving you C, the hypotenuse. Now I'm giving you C, but I'm not giving you one of the legs, the A or the B. You still follow the same Pythagorean theorem here. You just say a squared plus b squared equals c squared. You plug in what you know. You plug in what you know. Hey, you know what a is. You don't know what b is. You plug in c. We're going to have 36 here and 100. So we work out what we can. We still don't know what b squared is. Now we treat this like an equation. We just subtract off. I mean, it is an equation. You just subtract off the 36. If b squared is 64, you just take the square root of 64 to figure out what b is. And so 8 is your mystery number. All right. Composite plane figures. Okay. So what is the area of this figure? This can get a little bit confusing. But if you look carefully at this figure, this is basically just a rectangle and a circle put together. They chopped the circle in half and stuck it on either end. Okay. So all you have to do is figure out the area of the circle and the area of the rectangle and put them together. So area is length times width for the rectangle and pi r squared for the circle. So we have our length times width. We're going to substitute. Oh, before you do the substituting, realize that, yeah, this is 30, but for area of a circle, you only need the radius. So you're going to realize that the radius is 15. So when you plug it all in, length times width, pi r squared. Okay, there you go. Now you could use Desmos and it'll give you the answer, or you can show your order of operations. Either way, you're going to get about this as an answer. And there you go. Probability. What's the probability of your spinner landing on green and your number cube landing on 5? So if you have a spinner, let's see, this spinner, let's see, the green is taking about 1/4 of the entire thing. So that's going to be 1/4. Rolling a 5 is 1 out of 6. There's 1 5 out of 6. So we've got 1/4 times 1/6. And we're going to get 1 out of 24. These two events are independent of each other. The spinner has no effect on the number cube. We're going to move on. Okay, we're changing things around a little bit. Here now you have to mark these different markings and make the box plot. This is real easy. All you have to do is say, hey, the lower extreme is 12, you mark a 12. The lower quartile is 14, you mark a 14. The median's 19, you mark a median of 19. You mark your upper quartile as 22. You mark your upper extreme as 24. Now, you've got these markings. The 3 middle markings are your quartile markers. You're going to go ahead and mark those. And then the extremes get connected from a whisker. A couple years back, they used to call these box and whisker plots. Now they call them box plots. Here's your box, and then here's your whiskers. And we'll get more into that in the next few weeks. Just if you can understand the basic reading part of it, you're going to be set. All right, scatter plots. So we have these dots on a graph going downward from left to right. That's going to be a negative relationship. We don't know what x represents. We don't know what y represents, but we know as x goes up, y is dropping. As x increases, y is going down. That's a negative relationship. All right, simplifying expressions. So when you do this, you want to apply what's called the distributive property. So hopefully that's nothing brand new to you. The distributive property is when you have a number multiplied by a quantity. 4 times the sum of n and 3, 6 times the sum of n and -3. You just distribute the outside number to the guys on the inside. 4 times n, 4 times +3 gives you positive 12. 6 times n, positive 6 times n gives you a plus 6n. 6 times negative 3 gives you negative 18. From there, you just regroup. You get your 4n and your 6n together. You get your 12 and your negative 18, and that's going to give you negative 6. Just don't forget your integer rules. We're going to keep going. Okay, functions. Fill in the table, graph the equation. Okay, so we're going to fill in the table here. We're doing half of whatever x is minus 1. So y equals 1/2 x minus 1. When you set up the table, you're going to do half of 4 and then take away 1. You're going to do half of 2. Oh, and then we're going to plot a point. So 4, 1, we're going to put 4, 1 on the graph. We're going to do half of 2 minus 1. Half of 2 is 1. 1 minus 1, we get 0. 2, 0. We're going to mark 2, 0 over here. Half of negative 4 is negative 2 minus 1. That gives me negative 3. We're going to mark that. Negative 4, negative 3. Now you know you're doing this right when all your points line up along the same line. That's a linear function. Not a linear function, a linear function. The slope is going to be up 1, right 2. No matter where you go from one point to the next. Up 1, right 2, up 1, right 2. So that means your slope is 1/2. Now take a look at this. The slope is the same thing as the coefficient of x. The y-intercept is going to be where it hits the y-axis. That's negative 1. Notice how the constant in your equation up here is negative 1. And that's it. Now the big goal is for you to immediately just look at this line and this equation and draw the line without even having to set up a table. And we'll get there. All right, multi-step equations. So for something like this, we're going to solve for n. We want to get all the n's on one side, all your constants on the other. Personally, I like getting all my n's on the left side for some reason. So to get rid of this negative n, that's like negative 1n, I'm going to go ahead and add n to both sides. So they cancel each other out. 5n and n give you 6n. That negative 3 didn't change, and that 9 just drops down. These two n's canceled out, but the 9 drops. From here, it should look more familiar. You're going to add 3 to both sides and get this. The negative and positive 3 canceled out. 9 and 3 made 12. Now we're going to divide both sides by 6, and we get n equaling 2. Now you can always do a double check of this. Take the original equation, 5n minus 3, type that into one part of your Desmos, and then another line, do negative whatever n is plus 9. That's 10 minus 3, 7. Hey, this is negative 2 plus 9, which is also 7. So they do work out to the same thing. All right, the next one. Same process as the equation that we just did. Let's get all of our n's on one side and all of our constants on the other. So I'm going to go ahead and get rid of this negative 4n by adding 4n. That's going to give me 12n, and then take away 8. Everything else drops. That negative 4n and 4n cancel out. Now I'm going to add 8 to both sides, and I get negative 12. I'm going to divide both sides by 12, and you get n is greater than negative 1. So when you mark this, you mark negative 1, open dot. If it was an or equal to, then it would be solid, and it goes to the right. So negative 2 would not be a solution because it's not under the arrow. Negative 1 would not be a solution because it's not a filled in dot. It's not or equal to. 0 could be a solution to this answer. If I put a 0 up in here into both sides, it'll be a true statement. And that is, oh, don't forget, in this problem, you divided both sides by 12. You didn't have to reverse the inequality because it wasn't a negative coefficient. All right, that's about it. I hope this helps. Best of luck to you.